Welcome back, everybody. This is Parametric Philosophy, and you're watching episode 2 of Rhino Fundamentals. Now, in the last episode, we talked about the interface. I introduced you to, how to open up commands. We talked a little bit about layers and object snaps. In this episode, we're going to, take that next step and, what do we actually do with commands? We want to create geometry. That's really the most important thing. That's really what we want to use Rhino for. We want to create geometry. We want to execute our vision, whatever we have in our minds, in our sketchbooks. We want to create a 3D virtual model of that. Now, before we jump into Rhino, I just want to say it is important to understand whether you're. It's important to keep in mind whether you're creating some kind of schematic model for the purpose of visual representation, or are you creating a model that you want to be built or manufactured, whether that's 3D printed, CNC, etc. And the difference is that the amount of detail and the methodology that you're going to use when you're modeling is going to be vastly different. So when it comes to visual representation, certain modeling strategies are going to be a lot different. So I just wanted to put that out there, something to keep in mind. I want to first start off by defining all the different types of geometry that we will need to use when we're modeling in Rhino. And generally speaking, I've put sort of the more simple geometry at the top of the list.
Hey, what do you mean simple geometry? What are you trying to imply?
What the heck? No, I just mean geometrically, lines are more simple than the.
Is that all we are? Is that all we are to you? Just lines? We're just lines? Just lines in the space?
Yes. Okay, guys. When Rhino has a talkback feature, and sometimes it gets a little sassy. I don't know why. I think it's like a bug or something in the AI system or something. So remember, just go to the little check mark here. It's the talkback feature, and turn that off. Bye. See you later. Boop. Okay. You can't let Rhino control you. Rhino does not control you. Okay, so like I said before that interruption, we have sort of the basic geometry at the top, and as we go down the list, the geometry gets more complex. And really, the important thing to understand is that each level of complexity actually builds off of the last type of geometry. So let me explain. First, we have points. Points are very, very simple. Points are just an x, y, and z coordinate, and they don't really have any other data other than maybe the order that they were drawn in. And essentially, any geometry has point information. Okay, if I click on a line, there's 2 points. I click on a polyline, there's multiple points connecting together. And even if I click on a solid and I turn the points on, see, it's just a whole bunch of points. So any geometry basically has point information, or most geometry. And if we move up from points, we have lines, and lines are just 2 points connected together. So the information there is that the data in this line is what are the points, what's the sequence, how are they connected, and what is the order of the points? What does the line start? What is the first point and the last point? And it's simple for a single line, but when you get to polylines, the information needs to be such that there's a start point and an end point, and then what is the order of the points between the start and end point? Okay, so a polyline, poly meaning many, a polyline is a single line segment that has been joined together. You can join it, or you can create a polyline with the polyline tool. And just pushing that a little bit further, an open polyline is a polyline like this that is not the start and the end are not joined together. So the start, one of these points is the start and one of these is the end, and those 2 points are at different locations. But in a closed polyline, the start and the end do meet each other, and when you have a closed polyline, that can be used to create actually a surface, and we'll get to that in a few seconds. So all polylines are straight segments. All lines and polylines are straight segments. And when we get to curves don't need to be straight segments, but all lines are curves, but not all curves are polylines, right? So a curve could be a straight segment, but a curve can also encompasses any type of line that is straight or has a curve to it. And in this case, when it comes to curves, similarly to lines, a line is one straight segment, a curve is one segment of line. So the only closed curve that is possible is a circle or an ellipse or some type of shape like that. And when curves are joined together and the start does not equal the end, then you have an open polycurve. So you can join curves together to create an open polycurve. And then if it's closed, then it's a closed polycurve. Now in this case, we have straight line segments. So this is actually a curve joined to several lines, creating a polycurve. Because remember, any line is also a curve. So if there's curves and polycurves, or if there's curves and lines, then we're going to refer to it as a polycurve. And now we get to surfaces. So I mentioned that we can create each form of geometry from the last form of geometry. Now, if we use these points as an example, we can create a NURBS curve from these points. You can see that the control points match the point locations. And we can do the same thing if we go from a surface to from a curve to a surface. So we could take this curve, like I said, if we have a closed curve, we can use that to create a surface. And there's a lot of different ways that we can do that. Planar surface, okay? So now we have a surface. We could also create this type of curvy surface. We could take this curve over here. We could rotate it. Now we have two sets of curves. We can loft between them. Okay, and then we have something like this surface. It's a little bit different, but just to give you an idea of how we can build surfaces, we can build curves from points, and we can build surfaces from points, or we can build surfaces from curves. To give you an example of how we can build surfaces from points, we can do a 3-point or 4-point surface, just like this. Okay, and if we maneuver those points, we can change the shape of that surface. So generally speaking, any geometry that's in this list that's above the other geometry, we can build off of any of these geometries to get to the next form of geometry. So when it comes to surfaces, we have the same rules. We have open and closed. We have open surfaces and closed surfaces. And since a surface doesn't have any edges, it doesn't have any joined edges, the only form of closed surface, single surface, is a sphere or like an egg shape, like an oval shaped shape, because it has no joined edges, but it's still a closed object, a closed surface. And when it comes to open surfaces, a planar surface is one where all the points exist on one plane, and a non-planar surface is one where the points exist in three different dimensions, in 3 dimensions. Okay, so some of these points, if I turn the control points on, some of these points exist some of these points exist like in the planar surface, they exist in the XY plane, but some of these points do not. Some of these points exist somewhere else in the third dimension. Okay, but these surfaces, even though this surface occupies 3 dimensions, it does not have thickness, so it does not represent material. So you cannot use surfaces to build things because it still has an infinitely thin thickness, because it's still an open surface. So, and if we go to polysurfaces, just like the same rules with curves and polycurves, polysurfaces are joined surfaces. Poly, again, poly meaning many, so many surfaces, polysurfaces. And we can see these are actually not joined, so I'm going to join these. This is now a polysurface, one polysurface added to selection, because I just joined them. So I joined a surface similar to this with other planar surfaces, and this is an open polysurface because it still had the surface still has no thickness. And a way that we can think about an open versus a closed polysurface is, if you put it underwater, would it let water in? So that's kind of like, is it watertight? If you put it underwater, will water leak into it? And so a solid is a name that we call closed polysurfaces. So once you take this open polysurface, and if you can close it so it is watertight, that becomes a solid, and we can call it a solid, or we can call it a closed polysurface. It's the terms are interchangeable. So all solids are closed by definition. And the advantage of closed polysurfaces is that we can do Boolean operations. So I can take, and this is just a tiny introduction, but I don't want to get too into this right now, but I can take another solid and I can perform any type of Boolean operation, like a Boolean difference, or I can just cut away parts of this solid. And you can't do that with surfaces. It's a different procedure. It's not as simple. So I like to work with solids as much as possible. We can do other procedures. We can do a Boolean intersection, and it will keep both parts of the solids that intersect. So anyways, moving on to the last form of geometry. This is not necessarily, a mesh is not necessarily more complex than a solid, but it's sort of the odd one out, which is why I put it at the bottom. I would say, and this is called NURBS modeling, and this is called mesh modeling. And I would say that actually NURBS modeling is more complex, and a mesh is actually a very simple, it's actually a very basic type of modeling. But the key thing about a mesh is that it's simplified. It simplifies the form into triangulated surfaces. So these are either triangles or quadrants, or 4-sided quadrants, depending on the complexity of it. Now the key thing about mesh modeling is, I'll demonstrate here. If we still have the control points for a surface, if we still have access to this information, we can make adjustments, and we can still retain the smooth, like the smooth curvature of the surface. But if we try to do something like that after we've converted it into a mesh, we're going to get results like this, because the surfaces have been broken up. This surface has been broken up into multiple quadrants and triangles, and so now they all act independently. So a mesh model is just, it's very simple. It's just a collection of point information, with information also telling the points what the joining order is between the points. So mesh modeling, I'm not really going to get into much mesh modeling because it's really something that I almost never use. But just to give you an idea, a lot of people use mesh modeling for animations, for example, because you can associate each triangle or quadrant with a different color or texture or something like that, so you can actually get sort of a gradient of different textures. A lot of mesh modeling is used in animation of humans and animals and objects like that because of the rendering ability. And just to give you an idea, this is a very, very simple mesh model. It can be a lot more complex. We can make a mesh with a lot more polygons like this, or a lot fewer polygons like this. And a mesh with a lot of polygons is a lot more data, but the surface is going to be a lot smoother, okay? But again, if we turn this information on, now we just have a whole bunch of points. It's we're not going to be editing mesh models the same way that we would edit a NURBS model, but there are tools that we can use to edit mesh models if it's necessary. I'm definitely not an expert in that area. Okay, so I think we covered the basics of different types of geometry, and we started to understand some of the terminology that we're going to be using. That's where we're going to close for this episode. And in the next episode, we're going to start to get into a bit more about how to actually create the geometry. You know, that means how we're going to pull up commands and how we read command options in order to execute those commands properly and start creating the geometry that we need. So I hope to see you guys in the next episode. I'm out.